Okay, I will inform you, then you can start. Okay.
Okay, sir.
Sweta, you can start now.
Yes, sir. A very good evening to one and all gathered here. I am Shweta S. from the Department of Electronics and Communication Engineering and member of IEEE BTS. Here to host for today's event, Keras Fundamentals for Deep Learning. I cordially welcome you all to the 5 days workshop on deep learning and artificial intelligence using Python, organized by the IEEE societies. In the light of today's event, I would like to thank our chairman, Dr. B. Babu Manoharan sir, Managing Director, Mrs. B. Jessie Priya ma'am, Director, Mr. Sasi Shekhar sir, and Principal, Dr. B. Ravichandran sir. I would also like to thank our Professor and Head of Staff and Student FS, Dr. C. Nyanakausalya ma'am, and Lab FS, Dr. G. Rohini ma'am, for the ceaseless support. Now it's time to introduce about our today's speaker, Mr. Kamalesh S. He has 3 years experience in data science, machine learning, and deep learning, and having well knowledge in scikit-learn, Keras, TensorFlow, NLP, and Flask development of projects with upgrade technologies. Having a good technical strength in the frameworks like Anaconda Navigator, PyCharm, Python ideally. Welcome you, sir. Before starting, I would like to convey a few instructions to the participants. Kindly post your queries in the chat box and it would be moderated to the speaker at the end of the session. The more you learn, the more you earn knowledge. With that quote, I now invite our speaker to kindly begin this session.
Yeah, thank you for the introduction. Am I audible to all? Is it clear? Just for a confirmation. You can send an acknowledgement in chat box also. Am I clear to all? Yes, okay. So actually today's session is like previously we seen last day, that is yesterday we seen about how we can build the machine learning, but due to the insufficient time, we up to this we finished it, right? Like this, up to this only we finished in yesterday's session. So now we are going to finish how to build the model by using decision tree algorithm, and then after that we will enter into the deep learning using Keras and TensorFlow. Okay, so this program is like 2 part. The first part is like we will finish the yesterday's part. Okay, so we till now we didn't finish about how to train the machine learning algorithm and how to predict an output result and all. So after we finishing those things, will be move on to the Keras and TensorFlow introduction. Okay, so welcome to you all. So as I say thing, open your Google Colab, and then if you are having a data set, you can upload. Okay, so here you can see I'm connecting to the server. Okay, definitely I don't have a data set. It is yesterday's data set, and I need to run the previous cells also. So these cells are it's not till now run. Okay, so I'm uploading the data set first of all. Indian liver patient data set. So after uploading the data set, I'm going to run this cells. Okay, so for example, from here. So whenever you are going to run, open your notebook file, you have to run. Okay, without running, you will be not get an output result for the last code line, last code cell. So don't forget to run. And for this today's second part of deep learning with Keras and TensorFlow, for that session, I already posted my dataset link in our chat box. So those who are free, please download in between. The dataset here I'm using just a diabetes dataset only. Okay, so I posted in our chat box. So please download the link. Using that link, please download the dataset. After this I am going to teach you how the artificial neural network algorithm is working, and using Keras and TensorFlow, I'm giving the introduction how to build the artificial neural network algorithm. Okay, so it will be soon. Okay, so this part will be soon n. Why? Because it's just a few code lines are only there. Okay. So after that, we will start a deep learning. Now up to this, I hope everybody will understood. So just for go like recall. Okay. So I imported some basic packages and I reader my Indian liver.patient.csv file, and then I am checking for some duplicates, and then I am checking for some either we are having a null values or not, and then if we have a null values means we have to drop the null values. Then after this, I used some exploratory data analysis and I plot some graphs using Seaborn and Matplotlib. And after this, I converted my object. Okay, so here we are having an object type in our data set. So I'm converting my object type into an integer type. So finally I converted, then I checked the correlation of the each and every attributes. Then finally I'm here. So here what I am having means I'm just divided my data set into two parts. One is all the independent data. Independent data is nothing but the data of the report of the patient, each patient. Okay, so I'm saving it in X, and then dependent is nothing but output of the each patient, whether the patient will be attacked by liver disease or not. Here I'm having as a Y. So if, for your understanding, I'm printing and showing to you. This is X. Okay, in X we are having some attributes, but we don't have this output dataset column. Okay, in Y we will have the dataset. Okay, so this is the thing we done on previous session. So now, as I said in Paint yesterday, so whenever you are going for any training a machine learning model, you have to follow some steps like data analyzing and then future extraction and future engineering, and then fourth step like dividing our data set into two type classification, sorry, train and test. Okay, so up to this we done, right? Like train and test. So we are having now two data set, one is X and Y. In X we are having all the data, in Y we are having all the outputs. So now we need to divide our data set into two type. One is train, another one is test. So train always should be an like 70% and test should be a 30%. Suppose you can split train to 80% of data and 80% of data and here 20%. So our wish only based on the overall total values, we can split the data set into two type, train and test. Okay, so now I am going to show you how we can do this train and test splitting. Okay, so we are having a data set in separate variable, independent and dependent. So using this only we are going to divide. Okay, so I'm opening the code. First of all, I need to import some package. The package name is from sklearn dot model selection, and then import train and test split function. So we have inbuilt library package. In sklearn we have an inbuilt package. Using that inbuilt package only we are going to divide our data set. Okay, so the package name is train and test splitting. So normally if you need to develop in real-time scenario, you have to use like cross validation and k-fold cross validation, those things and all. Okay, so I didn't use here. It's just an introduction only, like what is machine learning and those things and all. So just you need to understand about how to divide the data set into two types. That's enough. Okay, so here I'm importing the data set. After importing the package. After importing the package, we have to divide our data set by using this function. Okay, so as I said in our Paint, we need train data. Okay, that is, for example, if I have 1,000 data, for example, I am telling if I have 1,000 patient detail, okay, I will divide this data into and two part, train and test part. Suppose if I divide the data set into 80% and 20% means in 80% of data, I will be have X and Y. Okay, randomly. So I already have this data. For example, if I have a data of first person, I have an output in this Y. If I have a data of 100th person in this data set in X, I will be have a output of that 100th person in Y. So we need to create a 4 variable, the variable name X train and Y train, and then X test and Y test. Okay, so I'm creating here new 4 variable, X train and X test, Y train, Y test. Okay, so here train is representing to train the algorithm, the data which available, 80% of data available in train and 20% of available data will be available in test. So to train the algorithm, that is X train is nothing but our data and Y train is nothing but our data outputs labels. Okay, like same thing only, X test is 20% of data and Y test is 20% of data output results. Okay, so I'm going to save by applying this train and test bit function. So within this function, we have to pass 2 parameters. The parameters we already defined, right? X and Y. So we need to pass the parameter of independent and dependent. So here I am passing X comma Y. Then after that, I need to mention how much percentage I need to divide my data set as a test and train. So here I'm taking test underscore size. So test size I'm giving here 0.2. Okay, test size I'm giving here 0.2. So 0.2 means 20% here. Okay, so 0.3 means 30%. So test size equal to 0.2, 20%. I am going to split as a test data. Then balance 80% of data will be automatically moved to the train data. So here the data, everything will be moved randomly only. We are not giving any specifically first 10 data will be moved to train and first 20 data will be moved to test like that. Okay. So after that, I need to give the random state. So what is the use of random state is whenever I am running this whole machine learning code, always my data will be a same only in train data and test data. That's why we are using random state equal to, I'm giving here random numbers 1, 2, 3, 4, anything. Okay, our wish only. Otherwise 1, 2, 3, our wish only. You can give whatever random number you need, you can give. So basically what the use of this means, your output accuracy score will not change. Okay, whenever you are executing this program, it will be constant. That is the use of this one. Okay, so now I hope you guys will be understood in this step. Little bit confused only, just analyze it. Okay, so what is X and Y, and here also we are having X and here also we are having Y. Okay, so just analyze it. I'm running this cell. After running this cell, I'm creating a new code cell and I'm showing you X train. So in X train, I'm having 452 rows and 10 columns. So 452 row means that is 80% of data will be moved to the X train. Okay, and balance 20% will be moved to X test. Suppose, for example, see here, guys. Here I am having an index value 513 in X train. My first input data is 513 index value. Okay, so in X train. Suppose if I print the Y train, I am getting the same index value 513. Okay, so now you will be understood. So whatever data here I'm having, the same data output will be available in Y train. So that is the use of train and test bit function. Okay, so now I'm going to import the algorithm. Okay, so I'm going to import the algorithm like from sklearn dot tree, decision tree algorithm I'm going to import. So I'm using here decision tree algorithm and then import decision tree. So note one thing guys, in supervised learning we have totally two type, right? One is decision tree, sorry, one is classification, another one is regression, right? Here you can see we are getting two type of algorithms. Okay, one is decision tree classifier, another one is decision tree regressor. So here I am using a type of classification type of data set. So I am importing the data set. Sorry, I am importing the decision tree classifier. Suppose if you are having a regression type of data set, you have to import decision tree regression. Like same thing only. Suppose if you want to import a random forest algorithm, you can use like this from sklearn dot ensemble technique. Okay, import random forest classifier. So here you can see we are having totally two. So like this you can import your algorithm. Okay, so the math behind algorithm is complex one. Okay, so here I'm just importing the data and I am showing to you. Okay, so as a data scientist you need to know even math behind how the algorithm is working and how we are getting output and all. But here there is no board also, so I'm just explaining you some theoretical part. Okay, so from sklearn dot tree decision tree classifier I'm importing. Then after this I'm going to create a model, the model 1. Okay, in this model 1 only I'm going to save my decision tree algorithm, decision tree classifier. Okay, so here model is nothing but our decision tree algorithm we are going to save in this model. But within this decision tree algorithm we are having a lot of parameters. Okay, so about this parameter I will tell you on 5th day of the class how we can do, what is the use of these parameters and what is the use exactly, those things and all I will tell you. Okay, at the starting time itself if I go went for these parameters mean definitely you can't understand. So I will tell you on 5th day how we can do hyperparameter tuning, what is the use of those parameters, how we can do hyperparameters and all. Okay, so just you remember about this. At the end of the class I will tell you, end of the workshop. Okay, so model 1, here I am taking some default parameters and save it in model 1. Then I need to train my model. So now my model is ready to train. So here I'm going to train the data. Train the model. Okay, so whenever you are going to train the model, you have to use the keyword or function model 1 dot fit. Okay, so if it is the function to train the model, so here you can see build a decision tree classifier from the training set. Okay, so x and y, and we are having some other parameters also, but here we need to pass x and y. So what is x and y for training? This one, x train and y train. So I'm going to pass the x train and y train. So these are my training data. So using this train data only, algorithm will be understood. Okay, how it's working, those things and all. So now I am going to train the model. Okay, so these are the default parameters what I taken here. Okay, so alpha is equal to 0.0 and class weight is equal to none and Gini iteration. So these are some parameters. About these parameters I am sure I will explain on 5th day class. Okay, so any one of the algorithm parameter I will explain it. Okay, next one I'm using here. Now I trained my algorithm. Okay, so now I trained the model. Now I'm going to pass my test data. So note one thing guys, for test data will be available in X test and Y test output only available. So here why is our output results are saved, right? Here I'm going to pass only a test data. Okay, so model 1 dot predict algorithm, that is decision tree model want to predict my input data user, and that is patient who are attacked by liver disease or not. Okay, so here I am using predict function and I'm going to pass the test data x test. Okay, x test. Here basically what I am doing here means I divided my data set into train and test. So I imported my decision tree model also. Okay, I saved my decision tree model. So I'm going to train the model by passing both input and output. Okay, so after I am passing the both input and output to the model will be learned from that train data. Then I'm going to pass only the input, that is only to patient report to the model. So for this patient report, the model will be give some prediction output. Okay, so the model will be give some predicted output like 1, 2, 1, 2 like this. Okay, so this is predicted output, right? But my actual output is available in y test. Okay, so when I compare this predicted output and actual output, that is called as a accuracy score. Okay, in machine learning. So that only we are going to do now. So now I'm going to predict my result passing x test. So model 1 dot predict x test. Then I need to save all the result in one output. So here I'm creating one new variable output. Okay, output is equal to model 1. So now I'm executing this cell. Then I'm creating a new code line and I'm going to print the output. See here, this is the output given by my decision tree algorithm. Okay, so after training my whole train data, model will be learned from the train data. Then I just passed my some input data, okay, to the model who is predicting the output, who are all person attacked by liver disease and who are all person are not attacked by liver disease, like that. Okay, so now we understood, right? Like model is giving the predicted output, but I need to confirm whether the model is giving a correct output result or whether it's giving a wrong output. So those things I need to do, right? I need to compare my predicted result and my actual results. So for that purpose, I'm going to use accuracy score. So accuracy score is available in sklearn and metrics. Okay, so metrics is one of the most important thing, guys. Here using metrics, I'm going to show you only one part of the metrics, that is accuracy score. But we have lot in metrics like confusion matrix, F1 score or classification report, dot recall. Okay, and lots are there. Okay, so but here I showed only an accuracy score, but checking the accuracy score is not a good one. Okay, so we need to check even F1 score or classification report, those things and all. Okay, so I'm just to give an introduction to you. You can keep in touch and learn from this part. Okay, import metrics, import, and then accuracy score. Okay, I'm going to import, then I'm going to find the accuracy score by passing the accuracy score function. So now what is the actual output? Okay, what is the actual output here? For example, you can see here, just wait a minute. So here you can see accuracy classification score. Okay, so here the parameters available is y true and y prediction. Okay, y true and y prediction. So what is the y true here? My y test, right? My y test data. Okay, my y test data is my y true. And then what is my predict data? That is saved in output result, right? Output. So my accuracy result will be, now I'm going to print. See guys, I am not doing any pre-processing steps on that. Okay, just I'm showing you training and testing. So even it may overfitting or even it may underfitting, or if it is underfitting or overfitting, we need to do some sampling methods or some other smoothing methods and all we have to do. But I'm not doing those things and all. Okay, just I'm giving you a introduction how we can train the machine learning algorithm. So print the accuracy of decision tree algorithm. So now if I print accuracy here, I'm getting an output 0.62. So this is not a good accuracy score. So, but for decision tree, I'm getting 62. So if you need to improve your accuracy score, you need to check like underfitting and overfitting and all. Otherwise, I will give just introduction to underfitting and overfitting. Okay. Sampling. Okay. Sampling techniques in machine learning. Machine learning. See here. So here we have a one picture. Okay, this is enough. This is called undersampling and oversampling. So when so this is one part. Okay, so when your model is actually, I am telling, when your model is overfitting or underfitting, first check whether your majority class and original class will be a same or somewhat like this. Okay, some class, for example, in our data set we are having total 2 and 1, right? So if it is a like this, okay, 2 will be a small and minority and 1 will be a majority, means you have to do undersampling. This also oversampling. So those things and all you have to see. This is the one part. Okay, but not only you need to do these things and all, you need to check even more some other things and all. Okay, so to reduce you to fit a generalized fitting. Okay, that is optimal fitting. So here we are having those techniques and all, but I just give an introduction to you. Okay, so this is what I need to tell you about machine learning, how to train the machine learning model and how to predict an accuracy score. Even though we are having a confusion matrix here and score value also here. Okay, so about those things and all, you just check it out. So let we enter into the deep learning part. Okay, using Keras and TensorFlow, the day 3, right? Day 3. Keras and TensorFlow. Keras and TensorFlow. So now we will enter into the next part of the class. So for this next part of the class, we need a data set. Here I am using the data set. The name is called as a diabetes.csv file. Okay, so this is the simple data set. Okay, using name itself, you will be get some suggestion. We need to predict then whether the patient will be attacked by diabetes or not. Okay, so this is the data set, simple data set. You definitely understood about this skin thickness level and blood pressure level and glucose level and then age. So those things and all we are having. So I'm going to use predict using this data set only, I'm going to predict use the simple artificial neural network algorithm. Okay. Neural network. Okay. That's enough. Okay. So now you have to import this data set also to the Google Colab. I'm going to use the import button. Just wait a minute. Okay. Machine learning, deep learning. So those who don't have the data set, please download it by using the link. Here I'm imported my data set, libraries.csv file. Then after this import, same method only, we have to import some basic packages. Like at the starting time, we imported, right? These packages. Same package. It's already imported, but for your understanding, I'm imported again. Okay. So this is the data set. So first of all, you need to know exactly what is the thing we are going to do in this next part of the workshop. Okay, I'm creating a new toolset. So what I am going to do means I am going to build the simple artificial neural network algorithm. Okay, so what is the simple artificial neural network means? Like we already discussed on first day. Like we are having an input layers and then hidden layers and then output layers. Okay, input, hidden, and output. So we are having totally this layers. So here I'm going to pass all the input data in my data set. Okay. So we have even like I'll tell you how to work on with the convolution neural network algorithm also by using images. Okay, so that and all I think tomorrow I will show you how we can build the convolution neural network algorithm. So tomorrow or day after tomorrow. But this is simple artificial neural network algorithm. This is just an introduction how you can use your Keras and TensorFlow package. Okay. So here I am applying some input. Then after this, I'm going to pass the input each and every hidden layer. So generally like this. Okay, so I already previous first day I told you, okay, this is fully connected layer and we have each and every line have some unique data. Okay, sorry, unique weight. Okay, so for example, here it's called as a W1, W2, like this will be have some weight. Okay, so based on the weight and based on the input values, okay, we are going to sum those data in hidden layer. Okay, we are going to sum those data in hidden layer. Then after this, we are going to pass it in output layer. Okay, so for suppose here we need to predict whether the patients are attacked by diabetes or not. That is whether 0 or 1. It's a classification type or it's a binary classification, right? It's a binary classification. So whenever you need to predict a binary type of classification, you have to use sigmoid activation function. Sigmoid activation function. Okay, so generally, if you are taking the neural network algorithm, you will be you need to understand about what is the use of activation function and what is the use of loss function and what is the use of optimizer, those things and all. Okay, so simply activation function, simply definition is use of activation function is it's tried to do your data in non-linearity way. Okay, it's try to give an output in non-linearity way. So that is the use of activation function. In activation function, we are having different type of activation function like sigmoid activation function and tanh activation function and ReLU activation function and softmax. Like this, we are having some different type of activation function. Here in today's session, I am going to use sigmoid activation function. So what is the sigmoid activation function range is like 0 to 1. This is the range of sigmoid activation function, and formula for sigmoid activation function is like 1 divided by 1 plus e power minus z. Okay, so this is the formula for sigmoid activation function. Okay, so now I'm going to apply the sigmoid activation function, and we are going to predict an output whether the patient will be attacked by diabetes or not. Okay, so that is the use of sigmoid activation. Suppose if you are here in our today's scenario, we are going to use even ReLU, activation function. So ReLU is nothing but it's one of the most important activation function and most efficient activation function. Why? Because in sigmoid activation function, okay, our output prediction will be like this. Yes, curve. Okay, that is 0 to 1. So here we will be have some threshold value, for example, 0.5. So if your predicted score will be a greater than 0.5, it's a 1, or less than 0.5, it's a 0. For how it's predicted output means here my score value after hidden layer, my score value will be 0.42, 0.23 and 0.65, okay, and 0.13. So here comparatively from all the score value, this 0.65 is the highest rate, and then 0.65 is greater than 0.5 threshold value, so it will be predicted as a 1. Okay, so that is the use of sigmoid activation function. So ReLU activation function range is this, that is 0 or x. This is the range. First, it will be checked whether it's a negative value or positive value. If it is a negative value, means it's a 0. If it is a positive value, means what is the value it will be give. It will be passed to the next layer. Okay, so that is the use of sigmoid activation function. Okay, sorry, ReLU activation function. Then you need to know what is the use of optimizers and then loss function. So why we are using optimizers and loss function? Why we are applying this optimization and loss function means, so here I am finally getting a correct one output result, one predicted output result. Okay, this predicted output result I will be take it as a generally what is the loss formula is y. Okay, the loss formula is y minus y hat. Okay, y minus y hat. This is the loss formula. Okay, here y represent the actual value, sorry, y represent the predicted value, and y hat represent the actual value. So what I'm doing in our machine learning model, the same thing only. I'm comparing here my y test and output result. Each and every data I'm comparing, like same thing only here also I'm comparing. Okay, so that is the use of this last value. Suppose if your predicted output result and your original result is not equal, using optimizer, okay, using one of the most efficient optimizer till now, the optimizer is called as an Adam optimizer, but we are having different type of optimizers like GD optimizer, gradient descent optimizer, or SGD optimizer, stochastic gradient descent optimizer, or even though we are having mini SGD. Okay, so we are having lot of optimizers, but Adam is one of the most effective and efficiency optimizer to point towards the convergence. Okay, so that's why we are any data set better you can use Adam optimizer. That's fine. Okay, here loss value. So here what type of output I need to predict? Binary type of output only. So I will use here loss function as a binary cross entropy. Okay, I will use the output as a binary cross entropy. Suppose if any other type of output prediction like multiple classification I need to predict means I will change my loss function. Okay, it is a categorical cross entropy like that. Okay, but here I need to predict a binary type of classification, so I am using a binary cross entropy. So that is the use of loss activation function, loss function, and then optimizers. Okay, so you will be get some information within this paint. Okay, but that information is just a 10% only. Okay, so if you need to learn even more what are the exact uses of this one, you just read the behind of this each and every function mathematics, then only you will be comes to know exactly what is the use. Okay, so here as much within this paint as much how can I explain you, I explained a lot. So we will enter into the technical part how we can build the simple artificial neural network algorithm. Okay, so I'm importing some basic packages. After importing the basic packages, I'm going to uh, like okay, so I will use train the algorithm. First I will run the algorithm, so run the model, and then I need to import libraries.csv. Import, sorry, using pd data is equal to pd dot read underscore csv, and then here I'm importing a diabetes.csv file. Then I'm applying here data dot head just for checking whether it's reader or not. Yeah, it's reader. So here I will open the data set to you. Here you can see. So this is our data set. In this, my output column is like, just wait a minute. Here you can see this is my outcome. Okay, so whether the patient will be attacked by diabetes or not. Here, this is all my independent column. This is my dependent column. Okay, so as I previously we seen in liver disease, like same thing only data set also. Okay, so here I erasing this. So what is the type when you are reading the any data in your uh, using pandas? What is the type of your data? It's in the type of data frame type. Yeah, you guys are definitely know about this data frame, right? But whenever you are training the deep learning or neural network algorithm, you have to give only the future. Okay, only the future is enough. Based on the future, it will be uh, learn and give the output result. But actually what we are done in previous in machine learning, what we are done, we are giving the future names, right? Here you can see age, this all the futures names, and then we trained the algorithm. But here I'm going to train without those future name itself. Okay, so now what I'm going to do means I'm converting my data frame into an array value. Okay, when you need to convert the data frame into an array value, you have to use just only one keyword. The keyword name is values. So if you apply data.values, then automatically it will be converted into an or your data into an array value. Okay. So as I showed in this same thing only without this future name, I am having my data set. Same thing, last column will be my output column. Okay, so here the last column, this one, my output column. Okay, so last column is the output column. Now I'm going to do some process with this one. Okay, so that is just we are going to divide our data set and then no need to divide the data set. So that is we already done. But I'm going to import some other basic packages also. Okay, so before that, same thing what we done here. Where is that? Independent data and dependent data. Like same thing, I'm dividing into two type. So I'm using here X and Y. X and Y. X is equal to data dot from ilog index location, and I'm going to take the particular location. In X, I need to say only this up to this, right? So here I'm going to use ilog, that is first all the rows in our data. Okay, so this is the thing represent, and next one from 0 to 8. So column from 0th column to 8th column. So 8 always n minus 1. Okay, so from 0 to 7th column, that is 0, 1, 2, 3, 4, 5, 6, and 7. Okay, so that is the use of here. The next part is like data dot ilog, then same thing only all the rows in our data set, but I need only one column. The column name is 8th column. Okay, so here I'm saving only 8th column. Here I am saving from 0 to 7th column. So finally we are get the both independent and dependent data. Okay, so for your understanding, I'm going to I'm going to print the data. So in X we are having like this data. Okay, so again it's having like this. Okay, just wait a minute. We need to save it in separate variable. Here I'm not saving any separate variable, so that's why here getting like this. I'm going to save data is equal to data values. Then now we'll see. I'm getting attribute array ilog. Okay, so numpy and ND array object has no attribute ilog. Okay, so for array type we don't have an attribute ilog. Then we have to use like this. Okay. Okay, so now what I looking for, it's exactly here in X. Okay, then Y we are having these outputs. Okay, so after converting my values, I'm saved in same variable name data. Then if I apply the data with ilog, I'm getting an error. Why I'm getting an error means for array type of data, we don't have an keyword ilog. It's only for data frame type. So that's why we are getting an error. So I just replaced this one. So now I am saved my X and Y. Okay. So that is the use of this one. Now I'm deleting this column. Save. So now it's time to learn about Keras and TensorFlow. What is the use of Keras and TensorFlow? So I showed in Paint, I'm having some diagram, right? This input layer, hidden layer, and output layer, those things and all. If you wanna build like this, input layer is this many neurons, and output layer I need this many neurons, and hidden layer I need like this neurons. If you need to build, you need to use Keras package. Okay, so Keras is the API to build your neural network model. Okay, so if you need to perform those actions, summation and then activation function, ReLU function, and then optimizer loss values, those things and all, you have to use as a backend. Backend is nothing but TensorFlow. Okay, so this is the uses of Keras and TensorFlow. But whenever you need to create any model in using Keras, you need some space, right? Within that space only you have to you need some model, right? So within this model only you have to build your input layer, hidden layer, and output layer. So generally that model is called as a sequential model. Okay, not only we are having sequential model, we are having a functions, and we have a lot. Okay, so most of the persons will be use this sequential model, okay, to build your architecture. So like same thing only here also I'm going to do from Keras. So if you are using Jupyter Notebook or Python, ideally this Keras package will be not available in your PC. Okay, so that's why I use it here Google Colab. So it's pre-built only, so we can directly import the package from Keras. I'm importing the models. What is that model name? Sequential. Okay, sequential. So now I get a model sequential, but I need to create the neurons like this input layer, hidden layer, and output layer. So this neuron generally called as a dense layer. Okay, this layers will be called as a dense layer. So here I'm using from Keras dot layers import dense. Okay, import dense. So this is the layers, this is the package I am going to import from Keras. After this I am going to build the model. Okay, so here I showed you, right? I am after importing the decision tree algorithm, I saved my model in model 1. Here I can use, for example, model 2. Okay, model 2 is equal to sequential model. Okay, model 2 is equal to sequential model. Then I'm going to build my architecture. So what is the first architecture? First layer in my first layer is input layer. So I'm going to build the input layer model dot add using dense layer. I'm going to build the input layer. Okay, so here it's asking how many units of that is how many neurons you need in input layer. So generally you can give whatever it is, but as we have a shape, right? We have a shape of X. I will check the shape of X. Sorry, X dot shape 8. Okay, so we are having a 8. So I'm going to build minimum well greater than 8 or equals to 8. Okay, for example, I'm going to give here 12 neurons as an input. Okay, I'm going to pass the input dimension. Input dimension. So what is the dimension? Now only I checked the dimension is 8. Okay, so you can give here 8 neurons, otherwise you can give more than 8 also, that's not a problem. After this, I'm going to use activation function. As I said before, you can use activation function relu activation function. Okay, so activation function is one of the most efficiency one for hidden layers and deep neural networks. So I'm using here relu activation function. Then model dot add dense. Here the next layer. What is the next layer? Hidden layer, right? I need to create the hidden layer. So hidden layer, how many units I need? For example, just for assumption, I'm having totally input dimensional 8. I'm passing 8. So more better we can go with 8. Okay, 8 neurons. It's not a mandatory you need to give exactly this many neurons in your layer. So I'm just using some assumption I am giving. Okay, so relu activation function. So now I create a totally what is the first? This is hidden layer, right? Sorry, input layer. Input layer, and the next one is hidden layer. The next one I have to build output layer. Sorry for this layer. Okay, so output layer model 1 dot sorry guys, here yeah, I made a mistake. Here I am having model 2, but I done with model, just model name. So now it will not show the any error, but at the compiling time I will be get an error. Okay, so model 2, model 2, model 2. Okay, so that is important. Then I'm adding dense layer. So according to my paint, my output, that is last layer, will be only 1 neurons. So I'm creating here only 1 neurons, and then I'm using here activation function is sigmoid. So now definitely you will be have a doubt why we are not using this relu activation function here. So as I said before, the relu activation function will be a give an output, the range is different, and sigmoid activation function range is different. Okay, so always relu activation function will be not applicable for output layer. Okay, it will be always used only for hidden layers and deep neural networks only. Okay, so not used for output layer. That is one of the most drawback and relu activation function. Okay, so here I am using sigmoid activation function. So generally sigmoid will be used for binary type of classification. Classification, if your output will be a 0 or 1. Okay, so I'm going to run this, build the architecture. Then after building the architecture, if you need to see your architecture, how it's building, you can use model2 dot summary, and then you can check your output. Okay, so this is the way our model is building. Okay, so this is the parameter. So that's why we are using this model summary. Now the next thing, now I build the forward propagation, right? This and all forward propagation. So when I when I give the data input, and then automatically my output will, that is this and all forward propagation. Okay, if you want to do backward propagation, we need this loss function and optimizers. Okay, so here I'm going to build those model 2 dot compile. Okay, in compile, the first thing is optimizers. I'm going to give an Adam optimizer. We have a lot of optimizer. For example, if you are taking an GD optimizer, it will be train all the data within at the single iteration. That is the use of gradient descent optimizer. If you are taking SGD optimizer, it will be trained one by one data, okay, in your train data. That is called as a SGD optimizer. If you are taking an Atom or mini SGD optimizer, it will be trained based on the batch size. Okay, I will tell you what is the use of batch size. Okay, in next step. So here I'm using optimizer Atom. Okay, Atom optimizer, and then I wanna use loss function. Yeah, exactly. So what is the loss function I need? Just wait a minute. Loss. So here I'm using a loss. My loss here I'm using an activation function. Output is binary classification type, right? Here I'm using binary underscore cross entropy. Okay, binary cross entropy. Next one is I need to check how my model is training. So I'm going to use metrics as we know before, right? What is the use of metrics? So generally, what is the use of metrics? You can find the accuracy score, right? Like same thing only here we are available in accuracy score. So during training time itself, how my model is learning, okay? To find that purpose, I'm going to use metrics and then loss function. So whenever I'm getting a loss value higher, my accuracy score value will be a low. Whenever I'm getting a loss value low, my accuracy will be a improved. Okay, so our main aim is we need to improve our accuracy score. Okay, so this is the compile function. Now, after this compilation, I'm going to create a new cell. Here I am creating model 2 dot fit. Fit, everybody will know now. Okay. So to train, we have to train the algorithm. So here I'm going to pass x, comma, y. Okay. X, comma, y. Now I need to give batch size because we are using here Atom optimizer. So here I will give batch size. Batch size is nothing but before you need to know batch size, you have to understand what is epoch. Okay, epoches. Epoches is nothing but how much time you have to train your train data. There is n number of iteration. For example, here I am giving here 20 time iteration. Okay, so each and every 20 time iteration, how much data we need to pass in my whole training data. Okay, so here I am giving randomly 50. Okay, so batch size is 15. Each and every iteration 15 amount of data will be trained and give the output result. Okay, so now I'm running this cell. Here you can see it's iterating first time, second time, third time, like this 20 time. And if you are getting if you are see your accuracy score result, here first time I'm getting a loss value is 25% and accuracy value is 0.30% only. Okay, the next time it's decreasing, right? First time getting 25.97, it's decreasing. So I already told you if it's a loss function is decreasing, definitely my accuracy score value will be increased. Okay, so here it's increasing. So like same thing only, if I see it for last iteration, 20 by 20 iteration, I'm getting 0.73 as a loss value and 0.63 is the accuracy score. So now you will be comes to know how much we are doing iteration, our loss will be decreased and our accuracy will be increased, right? So suppose if I do this one for 120 time means what it will be happen. Let's see. Here 120 times. Actually, this is a simple data set, guys. So that's why it's giving an output result within second. Okay. Suppose if you are using a picture type of data set or any other audio type of data set, means it will be take some time to train this 120 time. Okay. So here you can see I'm getting last value 0.5 and accuracy score is improving to 0.70. Okay, so this is the uses of your, that's why this is the way you need to train your data. Okay, so after your training, it's time to evaluate your result, how your model is predicted your output result. Okay, so I'm going to use model dot evaluate. Okay, sorry, model 2. Okay, we used here model 2 only, right? So after compiling, we need to do model 2 here. So now model 2 dot evaluate, and we are going to pass same x and y. We are not dividing our data set into train and test fitting. So just I divided as a independent and dependent value. I am passing whole data set to the model and train the model. Then now I am going to pass whole data set to evaluate my output result. Okay. So here I will be get a 2 accuracy scores. One is last value and then another one is accuracy score. So I'm saving here ACC. Okay. After this, I'm going to print the accuracy of my model. Okay. Accuracy of my model. So what is the accuracy score here? This 0.74. Suppose if we need to conclude this accuracy score, means you can use ACC into 100, 74% accuracy score. Okay, so my model at last I'm getting 73 as accuracy score for my training scenario. Sorry, 74 only. Here also I'm getting 74 accuracy score. But now you will be have one doubt. In both machine learning also we are just giving a data and we are predicting an output result, and in this here also we are just giving an output result. That just giving a data, we are getting an output result. So suppose if you need to give your own data, means you can give like this. For example, own data. I'm creating a new variable. Okay, so here I need to first I will print the x. I am printing the first row. So this is the first column. Okay, I am giving my own data here. np dot array, creating an array value. Here I am passing all the input data. Okay, sorry. Here I am passing the data. So here I'm getting only two. Okay, so I am getting here error. We need to. So okay, sorry guys. np.array value. Okay, so here I am creating the array value like this. Okay. Now my own data will be available here. That is input data 1, 85, 66, 29, and here this is my input data. For this input data, I have to predict whether the patient will be attacked by disease or not, diabetes or not. Okay, so I'm going to call my model. Okay, model 2, model 2 dot predict. So I need to pass my input data, my own data, okay, to here. Then if I execute this cell, I'm getting an error. What is the error? Value error. Input 0 of the layer sequencer is incompatible with the layer expected axis -1. Okay. Actually, here I taken from X, right? Here I taken from the X. So what is the shape of the X? What is the shape of the X? Like this. But now I given one input data. So what is the input? What is this shape? If I check the one data shape, yeah, this is the error. Okay, so here I am having 2D, but here I am having only 1D, right? So I need to conclude with this another bracket, square bracket. On data. Now, if I run this cell, I'm getting result like this. Okay. So here I need, it's asking axis -1, axis that is none. Okay, none comma 1. So we are having this axis as a none. So that's why we done like this 2D. So if I run this cell, I am getting an output 0.19. Okay, so 0.19 means minimum threshold value of, according to the sigmoid, we have a threshold minimum 0.19. So you can check your output. Okay, where we have taken this output from. Okay, so we are taking the output from X, right? This is my output. So this is the input, right? So in Y1 we will be have an output, right? So in Y1 I am having an output 0.0, and here also I am getting an output 0 point something only. Okay, so the output prediction is correct only, satisfied. So like this you can give your input data and you can predict your output result. Not only for here, you can check your output for even machine learning also. Okay, so like same thing, here you can create your own input and then you can create your output result. Okay, so that is the use of this one. So that's it about today's class, today's workshop. I hope everybody will understood about how we can train the machine learning algorithm and simple neural network algorithm by using simple data sets. Now this is the class I need to tell in today's class. Okay, so tomorrow I will use some other different type of data like image, tomorrow or day after tomorrow, and I will tell you how we can train the image type of data set using convolution neural network algorithm, and how we can build you build your own machine learning model by applying uh, some uh, some technique. Okay, so that and all I will tell you within this 2 days class. Okay, so even though we need to do hyper parameter tuning and how we can build the text type of classification technique, those and all we will see on upcoming 2 days. So that's it about today's session. If you have any other queries, you may ask now, and thank you all.
Thanks a lot, sir. The right questions provoke thinking and give way to actions and experiments. Now let us move towards the question and answer session. First question: how deep learning finds its application in signal or data processing?
Ma'am, once again, how deep learning?
How deep learning finds its application in signal or data processing?
You are asking me as a question, or I didn't get your
Question, sir.
question. Ma'am,
How deep learning finds its application in signal or data processing?
data processing only, ma'am. Ma'am, I didn't exactly, I didn't get your point. You can better skip the question next one.
Okay, sir.
What is the next question, ma'am? Otherwise, you can remodify your first question and you can ask it again. What is exactly you are looking for? I don't know.
Next question, sir.
Okay.
Which one works better, ReLU or sigmoid activation function, and why?
Yeah, that's a nice question. Actually, which one act as a better? That question is good thing only. But according to the deep learning, based on its data set only. Okay, so suppose if your data set in the form of like today we are using one data set Excel sheet, or in the form of only an binary type of classification or some other thing, means you need to use that particular output. Here you can see sigmoid activation function. Here I am using ReLU only previously, but I'm using here sigmoid. Okay, why I'm using means ReLU have that much capable to predict an output because the range is zero, starting range is zero only. Okay, but sigmoid have a range from 0 to 1. Okay, so here I don't tell the ReLU is better or sigmoid is better. So based on the data, it will be changed. The way of role will be changed, ReLU and sigmoid.
Thank you, sir. The next question: what will happen if the learning rate is set too low or too high?
Yeah, too low and too high. If you are getting a learning rate too low, means that is generally called as a underfitting. I means overfitting. So if you are getting like this too low, your learning rate will be low and high. That is low bias and high bias means your model is not learned properly. You have to do some pre-processing steps like minimax scaling or normalizing or standardization technique. Not only those techniques, we have a lot of techniques are there. So you have to apply those technique and you have to find the optimal fitting of your algorithm. So if your model will be an high or low, means it will be not given exact output result what you are looking. That is the answer.
Final question, sir. What is the use of deep learning in today's age and how is it adding data scientists?
Yeah, actually, it's a one part of data science scientist. Okay, so just you need to do some process with your data and you need to build your model. Okay, suppose if you need to full that is basically what is the end-to-end project of machine learning is, after you are building train the model, you have to build your own machine learning model and you have to use that model to your web application or Android application or some other uh, thing. Okay, so here the scenario is, if you wanna uh, if you wanna data scientist, you have to learn even more. And most of the thing, the data science is the huge thing. Okay, so even I also learned some bit of information only. We have a lot of things, so we need to learn even more if you want to become a data scientist.
Thank you for clearing our doubts, sir. And now it's the time to express our gratitude. I, Shweta S., on behalf of the Electronics and Communication Engineering, St. Joseph's Institute of Technology, St. Joseph's Group of Institutions, I extend a hearty thanks to Mr. Kamalesh, sir, for making this session more informative. My heartfelt thanks to our beloved chairman, Dr. B. Babu Manoharan, sir, for his consistent upkeep in conducting this workshop. My sincere thanks to our Managing Director, Mrs. Jessie Priya ma'am, and our Director, Mr. Sasi Sekhar sir, for the guidance in conducting this workshop. I also thank our Head of Department, Dr. C. Jnana Kausalya ma'am, Staff and Student Affairs, Dr. G. Rohini ma'am, Lab Affairs, and all the faculties for organizing this event successfully. Last but not the least, I thank all the students for their active participation. This series will be continued tomorrow at 6 p.m. on neural networks in Keras. Thank you all and stay tuned.